decompress the hyperinflated part of the lung. So again, this study is called EASE, double-blind, randomized, sham-controlled. Now all of our studies are sham-controlled. It's mandated by FDA to rule out the effect, psychological or physiological effect of just having a bronchoscopy. Multi-center, done in about 20 different 24 centers or so in 14 or 13 different countries. And here was the hypothesis that degenerated, tissue destruction, collapse of these small airways, air trapping, hyperinflation, leading to work of breathing, and then eventually leading to dyspnea. And then if you somehow can break this cycle of air trapping and hyperinflation by generating an artificial air leak, then you will not have hyperinflation and you will not have all the consequences of that leading to work of breathing and dyspnea. So this is how the procedure is done. Again, flexible bronchoscopy, no surgery, under general anesthesia. You go in with the bronchoscope, and first we put Doppler probe to see where the blood vessels are. And Doppler probe tells you that you are towards the vessel. If you're not, and then you change the site and you Doppler again, it's just a sound Doppler. If there is no blood vessel there, then you're safe to go ahead and make a tiny hole in the airway. And then pass a little catheter and inflate a balloon. There is a little stent loaded on a tiny balloon that you deploy and keep the airway open. You're doing Doppler again to make sure that hole is in the safe place and not near the blood vessel. So after the hole, you Doppler, and then you go ahead and inflate this balloon, which has a stent on it. Once you remove the balloon, the stent is deployed. And here's the artificial airway, which allows trapped air to come out. Now, because granulation is very easy in these tiny airways, these valves or stents were loaded with antifibrotic agent. It was a very clever concept. And we did hundreds of patients. This is a tiny valve. This is silicone membrane, lateral framework, and the whole stent is drug-eluting. Again, double-blind, randomized, sham-controlled, 255. So we actually ended up doing close to 300 patients around the world. And valve placement was not very complicated. And this is an artificial airway, and this is the real airway. But, so initial data looked okay. At 6 months, most of the responders had improvement in their FVC, about 12%, and about 1 point improvement in their MMRC. But these were both sort of co-primary endpoints. We didn't get in most of our patients both endpoints. We got MMRC in most of the patients, but not 12% improvement in the FVC. So 315 patients in 40 centers. So we got FVC, but not MMRC, or other way around, MMRC at 6 months. So MMRC alone was statistically significant, but not FVC. And that, since it was one of the primary endpoints, FDA didn't like it. We didn't have any major complications. And from my personal experience of doing several patients of these, most of them had benefit in the first month or so. Despite all our efforts to have the drug-eluting valves, and most of the valves got closed by tiny mucus plugs, or they were coughed out. I had at least 2 patients who came in with little tiny things in their hands. So I told them to just put it into a tiny Ziploc and bring it to us so we could keep count of those. Because we would sometimes put 12 or 14 or 16 holes and valves in there. In the early part, we had complications of bleeding, because one patient, and I think in Pennsylvania or Cleveland, had a blood vessel punctured and had massive bleeding. But otherwise, there was no death. Death, one happened during our EASE trial, but that was because of aortic aneurysm. But anyhow, since we didn't get to our primary endpoints, FDA didn't like it, and they were already a little bit skeptical about the how involved this procedure was, so they did not grant permission to market this product. So this study is also actually on the drawing board again. We're trying to figure out if we can do it on a limited scale in some patients and somehow keep the valves open. This is one of the most recent, even crazier idea of doing it. So the first trial went on in Germany. It's called Numorex. It's a new technology. Basically, it's a straight. It's a wire. It's a spring, which, when released, takes this shape. But you can stretch it open and make a straight coil. So the whole concept was, now you probably already are getting a very good idea of the whole concept, is somehow take out the upper lobes by surgery, by blocking it, by valves, or making holes and deflate it. Somehow just take them out of the equation because they are the problems in heterogeneous emphysema. So in this, what the concept was that you place this thing straight into the airway with a bronchoscope because it's stretchable. And as soon as you remove the bronchoscope, it goes into this shape and completely coils and twists the airways. As a result, they kink and there's no air movement. So Germans came up with the idea, and they did the first trial in Heidelberg. And it's not published yet, and I think I'm allowed to say that they had way too many complications of pneumothorax. So this is how it goes. Flexible bronchoscopy being done, and then see how straight it is, and as soon as and see how it's pulling the lung. So now it has pulled the lung. The airways that were straight are now twisted, and the tortuosity has basically blocked the airflow. So it was a kind of crude way of doing it, and it worked in the animals and in some humans, but now the complication rates are high enough that we're not even starting this study in the States.
You can't take that out either. Is that true? Or you can't?
Initially the industry claimed that you can, but it was, again, taking it out was a major issue too because it was ripping the airway and causing the damage to the airway. This was a very neat study by Ed Geneva from Boston. He's a very smart scientist and a physician in Boston. He came up with this biological glue that will basically go and block the airways, and some of it will go actually into the lung tissue and scar and fibrose the lung tissue. So it's basically liquid when you put it in. And he initially started doing bullectomies with this in animals. He developed bulla by giving them a lot of cigarette smoke, put them in the box and pass the cigarettes, and they smoke for years and years and develop emphysema. And then he developed Paquin model and started destroying the lung tissue by that way. And then he would inject this glue, which basically looks a lot like, the cock in your bathroom. So 2 syringes, both of these different chemicals get mixed here, and then in a few minutes after that, they turn into hard gel and block and become hard, actually, putty. That's a good term. You put a putty, it changes color, it becomes hard. And he did several trials in people who were going for surgery. It was pretty effective. Then actually, the Temple, Jerry Kreiner did a study of 6 patients. And they had decent success in the initial human and animal patients, but a couple of patients developed really bad post-obstructive pneumonia and sepsis. And one of the most dreaded downside of these procedures is that if they're not reversible, then if you have a tension in the thorax or you have post-obstructive pneumonia, you can't deal with it. And this was irreversible. So a couple of patients had sepsis and other problems. Company stopped it, and then there were some other ethical issues. The PI of the company was also the owner of the company that makes it, Ed Geneva. So there was a lot of issues. So basically, it's on hold now. It's not completely off the table. It's just on hold, and I think he will come back and somehow according to him, there's a way to reverse it. If he injects